Project finance revenue is driven by forecasting whatever we're counting in the project. In renewable energy, a technical consultant provides a net capacity factor, or NCF, forecast. In a toll road, it might be a traffic flow forecast. But these forecasts, they share one thing. They're probability-based, and they're wrong from day one.
So, should we just ditch them?
Absolutely not. A forecast doesn't give you the answer, it gives you a range of possible answers. And with enough data or enough combinations of conditions, those outcomes start to behave like a normal distribution, just as our friend, the central limit theorem, would suggest. Dylan, take it from here.
Gladly. Let's focus on the energy example. Forecast values are labeled using P factors: P50, P75, P99, and so on. These are probability figures. They describe the chance that a project's net capacity factor, meaning actual generation as a percentage of maximum capacity, ends up higher than the forecast value. A P50 forecast means there's a 50% probability of exceedance. The P50 that we receive corresponds to the mean generation of both a single distribution and all possible future distributions. Essentially, the mean of all the distribution curves. You can think of it as the mean of means.
The next question is, how does each party use these P factors? Each one gives us a specific net capacity factor, which then feeds into the generation calculations. The formula is nameplate capacity times time times the net capacity factor. Nameplate capacity is the total installed capacity of the project. Time is the number of hours in a year, 365 days times 24 hours, or 8,760 hours. So the formula becomes nameplate capacity times 8,760 times net capacity factor. Once we have generation and price, we get revenue. That's why net capacity factors and the P factors behind them are major drivers of value.
Let's take a 100 megawatt project with a P50 net capacity factor of 20%. So we take the project's capacity, 100 megawatts, multiply it by 8,760 hours in a year, and then by 20%. That gives us 175,200 megawatt hours per year. This is the long-term average. Some days, months, or years will be higher, some lower, and investors understand that variability.
Now, suppose I'm equity. I might use P50 as my base case since it reflects the expected long-term average and returns a reasonable level of generation and thus revenue. But I may also run a more conservative case, say P75. A P75 means there's a 75% chance of exceedance, which implies a lower net capacity factor and therefore lower expected generation. In our example, the P75 net capacity factor is 18.5%, resulting in 162,060 megawatt hours per year.
Hold on, Mr. Equity. As a lender, I may look at this very differently. I don't benefit from upside performance, but I feel the downside if generation drops. So I may focus on much more conservative assumptions, like P99. A P99 reflects an extremely cautious outlook. Here, a P99 net capacity factor of 15.4% results in 134,904 megawatt hours per year. And I don't take these P factors at face value. I pair them with debt service coverage ratios. For example, I might require a 1.3x DSCR on P50 cash flow, which gives me a reasonable buffer using mean generation. At P99, I may only require 1x, because if the assumptions are that conservative, I want to break even at minimum. Depending on the project, I may look at several P factors, or even a combination of them. As a quick note, renewable energy net capacity factors have historically been overstated. Actual P50, P75, and P99 performances have often come in lower than projected.
Remember, these are forecasts, they're not reality. Lenders and equity may even use different versions of the same P50 based on their own consultants and own assumptions. A lender's P50 might drive debt sizing while equity uses its own P50 for returns. And this logic goes well beyond renewables. Toll roads, mines, and other infrastructure projects all rely on forecasts and their variability. So make sure that you understand what each P factor tells you. And of course, hire good technical consultants.